Hello everyone, my name is Jonas Fu, and today I want to talk about a scenario-based analysis of possible savings implementing continuous descent approaches with lateral rerouting, which was part of my master thesis here at the Institute of Flight Guidance in Braunschweig. First of all, let's have a look at the overview. At the beginning, I will briefly present the objective of this research. After that, I will talk about the data sources and models used by the simulation software, which are present in section 3. In section 4, I will give you some insights to the generated dataset and discuss the comparison between the simulation and the corresponding ADS-B data. Finally, I will give you a summary and talk about some further research which can be done in the future. So let's get to the objective. Currently, continuous descent approaches are mainly carried out during night hours because the application of this procedure leads to a reduction of the traffic capacity of an airport. In a continuous development of efficiency increase of flight patterns, the objective of this research was the determination of possible savings by implementing an algorithmic rerouting of inbound traffic within terminal maneuvering areas. In general, this research is meant to be a theoretical consideration with conscious simplifications. Without any application of lateral restrictions such as waypoints or noise constraints, a completely free lateral routing is possible in this consideration. So besides the manipulation of the vertical flight path, also the lateral track should be optimized. For the simulated approaches, waypoints and standard arrival routes should not be considered to gain the maximum optimization potential. As I mentioned before, the application of CDAs lead to a reduction of the runway capacity due to different aircraft performances. So another goal of the optimization was to hold at least a comparable runway capacity after the rerouting process. For the deduction of calculation parameters and to obtain real-world trajectories, ADS-B data should also be collected. Finally, a comparison of the calculated CDA trajectories and the collected ADS-B trajectories should be carried out on the basis of multiple scenarios at 3 German airports. As you can see on the right side, the choice fell on Frankfurt, Hamburg and Munich. The blue circles mark the examined sectors around the airports. Here they all have a radius of 135 nautical miles. Okay, let's go to the data sources and used models. The OpenSky network was used to obtain the ADS-B data for the following comparison and derivation of important events for the simulation. Wind direction and speed, which are important to calculate fitting CDA trajectories, were taken from the global forecast system by the National Oceanic and Atmospheric Administration of the United States. For the calculation of the aircraft performance, the OpenAP toolkit was used. This is a research from Sun et al. And an open source alternative to the common BADA model by Eurocontrol. Now I would like to show you the data flow of the used air traffic simulation software. First of all, the raw ADS-B data from the OpenSky network is downloaded. After that, a derivation of multiple events during a detected incoming flight, such as sector entrance and the timestamp and runway of each touchdown, is possible. Based on these derived events, a recalculation of each approach, beginning at the sector entrance point, with manipulated vertical and lateral flight path is carried out. Okay, let's shift to the analysis of the simulation data. As a short introduction, I would like to show you an example scenario. This is the traffic situation at the Munich airport on December 17th in 2019. On the left side, you can see an overview of the airport. In total, the airport has 2 runways, which can be operated completely independent. On the right side, you can see 2 maps, which are showing the same area around the airport. The upper map depicts the trajectories of the ADS-B data, and the lower one shows the calculated trajectories by the simulation. As mentioned before, the simulation didn't consider any standard arrival routes or waypoints during the lateral rerouting process. Just in case you wonder why the approaches in this scenario are operated from both sides, during the day there was a change of the operation direction at the airport. In general, scenarios for each day between the 8th and the 22nd of December 2019 for each examined airport were analyzed. On this slide, the relative changes of some comparison parameters from ADS-B to CDA trajectories is presented. Each category shows the 3 airports and an average of the values. So let's start with the distance. On average, the calculated CDA trajectories are about 7% shorter than the ADS-B trajectories. Moreover, the approach duration is also shorter. The maximum saving here was detected at the airport of Frankfurt. The average speed of the CDAs is for Frankfurt and Munich higher and for Hamburg about 3% lower. In each case, the average fuel consumption of the approaches could be reduced, in Frankfurt nearly by 10%. The capacity of the airports could be held at the level of the traditional approaches, even while applying CDAs. Finally, I would like to show you some altitude profiles of the different airports. As you can see, the profiles of Frankfurt in general are a little bit lower than the profiles of Munich and Hamburg. The difference of the optimal CDA profile, here depicted in green, is in total higher than the difference of the profiles from Munich and Hamburg. This could be an explanation why the optimization potential at the Frankfurt airport is higher than the potential at the other ones. Okay, so summary and outlook. Considering all examined airports, an average fuel saving potential of about 6% could be identified. The possible savings highly depend on the capacity utilization of the airport. The airport capacity could be maintained at a similar level despite savings. Lateral constraints were not considered in this research, but can be added to the simulation environment in the future. And some further studies should cover an implementation of the BADA aircraft performance model to ensure comparability with other studies, and also a consideration of the extent to which changes can be made to the air transport system to allow even freer routing. So in the end, thank you very much for your attention.